Eddie, what's the radiant point of a meteor shower?
I do not know.
You said the inside of the tunnel.
Yeah, it's the point in space from
What's the
which a
vanishing
meteor
point?
shower appears to be emerging from the sky.
Okay.
And it takes its name from whatever constellation happens to be occupying that portion of the sky. So therefore, Darren, what constellation would be the Taurids? Karen got it, come on.
Yeah, Taurus.
Oh, okay, good. How about the Draconids?
Draco.
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 Right, yeah.
Is there a Draconid meteor shower?
Yes, it peaks on October 8th. Yes,
I know about the Perseus too.
yes, and that would be what constellation?
Climanestra.
No,
Oh,
Perseus.
Agamemnon. No, Perseus.
So I have no idea if this was part of anything. I really don't know. But Paul and I were talking about this last night. As far as the Tunguska, it happened at 7:30 roughly, June 30th, 1908. Now that's the peak of the summertime torrents. So the position in space, which would be the azimuth position, which is the position above the horizon and the position from 0 degrees longitude, basically that position exactly coincided where the position of where one of the summertime torrids would have been coming from. Now, the thing is if you go out in the fall time torrids, they're coming from space. You know, they're moving in towards the sun. So the orbit lies very close to the Earth's plane of the ecliptic. So the Earth passes through the stream twice each year, right? So if it's passing through the summertime torrids, at that point, the stream is coming from around the sun. It's made its perihelion passage. And who wants to tell me what perihelion means?
The sun.
No, what's perihelion?
Oh, it's the furthest extent of the
No,
Earth.
no. You're opposite.
Oh.
It's the closest extent
Okay.
to the sun. The aphelion is the
Helio,
farthest.
sun.
Okay, so it makes that close passage around the sun, and then it's coming back from the sun. So just like the eyewitness accounts place the position in the sky of the Tunguska object is, you know, some of the eyewitnesses described it like it looked like this, it was being thrown out of the sun, being born from the sun, right? Because it's coming from that direction. It just made its perihelion passage. So obviously when it's coming from the direction of the sun, it's going to be largely invisible until the last few seconds, right? Now, if it's coming at the fall time torrid, you're looking out into space away from the sun. So that's when you can actually see the torrids, and you can see them coming in, and they almost bullseye right on the Pleiades, the shoulder of the bull. And when you know that, and you realize that there's a lot of astronomical evidence that the torrid system was much more active in the past than it is now, it's very possible that ancient peoples all over the world were seeing and witnessing things in the sky that were occurring. And so a lot of the ceremonies and the symbolism associated with the bull and the Pleiades and so on could be associated with the torrids. And where I think, for me, where there may be a connection with the electric universe theory is that I think that there would be a voltage potential between any objects entering the atmosphere and the Earth. And that could then trigger very large-scale discharges. And I think that there were reports of lightning associated with the Tunguska object.
Do you think the Younger Dryas impacts were from the Taurid meteor stream?
At this point, I think that's the primary candidate. Yeah, for a number of reasons.
Is the Taurid stream the most impactful on Earth, or could it be the Leonids or another?
Right now, it's hard to say, but in the past, the Taurids were probably the most dominant one. In terms
Although the Younger Dryas impacts were during the age of Leo, is that right?
The Younger Dryas impacts would have been right about the transition from the age of Virgo to the age of Leo, which is the position of the vernal equinox. Right, which is interestingly if you've ever read Hamlet's Mill, you know, and they talk about the model of the great year. You know, one of the let's say potent positions that comes out of that study is the transition from Virgo to Leo, which would have been half of the 26,000 year cycle ago. And this was something, I mean, I think I read that book in the early 70s, and so I always had that kind of dating in my mind of around 12,900 years. And then, of course, when they dated the Younger Dryas boundary, 12,900 years. So I thought, voila, there we go. Duh. You know, that was one of those moments of, so.
Well, there was Plato's commentary too.
Yeah.
Based on
Plato, and Plato, yeah.
What was his name? He was relating what another scholar had said who was from Egypt.
Solon.
Solon had access, I think, to sky
Yeah,
maps.
Solon did a
He had sky maps.
10-year exile in Egypt and had access to all of the Egyptian elder priests who told him the stories of Atlantis. And he brought those back to Greece.
Well, and the timing of it though is the 9,000 years.
Yeah, 9,000 years before. So
1,000 years
when Critias at the forum was telling the story, see, because Solon was his great grandfather. So he says 9,000 years prior to Solon's journey to Egypt, which took place about 600 BC. So how interesting is it that Plato gives the date for the destruction of Atlantis that would have worked out to about 11,600 years ago, which has now been the date of Meltwater Pulse 1b in the beginning of the Holocene.
There's
Coincidence?
There's more
Yeah.
evidence than just that too.
Right. I find that very interesting. So I kind of think that was the last really serious gasp where you had large-scale melting of the residual ice sheets. I think you had the first, if the current dating is correct, the first huge meltwater pulse from the ice sheets back into the ocean was at 14,600. Then there would have been a second melting event at 12,900, and then the final big melting event at 11,600. So you have meltwater pulse 1A that was identified maybe 20, 30 years ago, which would have been the 14.6. Then you had meltwater pulse 1B, which was the 11,600, and only within the last decade or two have they identified large-scale melting events at 12,900 that coincide with the Younger Dryas boundary. So it appears that there were three major catastrophic pulses that ended the last global ice age and inaugurated what we're in now, the Holocene, which is an interglacial age. So I find that to be quite interesting.
But it's timing. The timing works.
Yeah, and so the whole transition was taken about 3,000 years, and within that 3,000 years, it appears that there were three major catastrophic events, and it took three in order to kick the planet. Once you're in an ice age should be self-perpetuating. So it takes something to knock the planet out of an ice age.
Well, it might have started the wobble. An extra bit. If it was that significant, it might have altered the wobble slightly.
Well, and here's
or
another.
even created the wobble. Maybe it was rotating like Venus, and bam, it got hammered by stones twice a year.
I have seen some mathematical work that would suggest it would take a much larger, almost even something the size of half the size of the moon. We're not talking about that. The events of 12,900 years ago are considerably smaller than, for example, the KT event that exterminated the dinosaurs. There's no 150-mile wide crater on Earth associated with the Younger Dryas. But I think what we're looking at, though, is multiple impacts that impacted the northern hemisphere, and a lot of them were into the ice sheet, which was anywhere from 1,000 feet to 1.5 miles thick. So what that does is creates a whole different crater, more fun. You wouldn't see something like this. What you would see then is if you had, picture if we're sitting here and we had 1/2 mile of ice over, and the thing struck, then what would happen? Well, there would probably still be an excavation in the ground, but there'd be a tremendous amount of meltwater generated from the enormous heat and pressure, and that meltwater is going to rush back into the crater, the transient crater it's called, and it's going to bring a lot of sediment with it, and it's going to largely fill up the crater. So, you might have just a circular feature, but it's shallow. But if you were able to remove the sediment that was washed back in, then it would be considerably deeper. And if you watch my most recent podcast, I identify two potential impact sites that would have been under the ice sheet. One is now occupied by Lake Nipigon, and the other one is occupied in Manitoba, and the other one is occupied by Lake St. Jean in Quebec. And Lake Nipigon catastrophically outflowed into Lake Superior, and Lake St. Jean catastrophically outflowed into the St. Lawrence Seaway. Now, there have been microspherules found in Pennsylvania that have the same geochemistry as the site of Lake St. Jean, which to me was strong evidence that was, and those microspherules would have required heat of close to 4,000 degrees Fahrenheit to produce, based upon the chemical, and then transported from, Quebec to as far south as New Jersey and Pennsylvania.
Could they be light enough to float on the air for a while?
Oh yeah.
Not just be propelled by the impact, but lose that
Yeah,
force.
and I mean, because microspherules could then, they could get carried aloft by winds and transport, because microspherules have been found, for example, in Syria and in Patagonia. Now, how did they get there? And they're dated to the Younger Dryas. Now, there's evidence of major, and Paul, have you seen the study showing major melting in the Alps dating to the Younger Dryas?
I haven't.
I'll have to send that to you so you see. But yeah, so impacts, an impact event over the Alps that dates to the Younger Dryas, a major discovery of impact proxies as far south as Patagonia. Recent studies have even now found impact proxies in Antarctica. So it's like some of these things have been like transported around the entire planet.
As the volcano one that blew up in the Philippines.
Yes.
It changed the atmosphere in the United States.
Yes.
You could see it.
Pinatubo.
But
Is that what you're talking about?
But what about those two impacts in Canada? Is there any evidence of an electrical universe idea? Is there any evidence of a plasma bolt?
That I don't know.
'Cause
That
it
I
went
don't
through
know.
the
I haven't
ice.
seen any. That's not to say there wouldn't be, but like Paul and I were talking about, I think that when you have something like that entering an atmosphere, you're going to have electrodynamic processes that could create a tremendous voltage potential between the object and the Earth, and undoubtedly, I would think would likely give rise to electrical discharges that could be pretty substantial.
I was thinking maybe when it hit the ice received a plasma bolt. When it hit the ice, a plasma.
I don't know. I guess.
I have a question. Just looking at the center of the crater here, this has been here 50,000 years, and you
Okay.
think that things have eroded over time. A little rain we get here, but still, things have washed down, and you have sediment that would fill the very bottom. Look at the very center. It looks like a different kind of dirt down there.
Yeah. It's probably most of this around here is this Mullen-Copy sandstone, but then there are also layers of limestone, and that could be what we're seeing here. That could be
Whitish.
Yeah.
That whitish circle right in the middle.
Yeah.
That could have been from plankton or other creatures dying and leaving a skeletal.
Yes.
Yeah,
'Cause
so
that's where limestone
After
comes
the
from.
impact, after it filled up with water.
Yes.
Yeah, it was a lake for a while, you said.
Yes. Post